Part 2 is AI technical architecture. In this part, I will introduce the technologies and applications are involved in AI. Please look at the AI architecture. As we mentioned, the third wave benefits from big data and powerful computers. The improvement of computing capacity and growing of data are the basic of AI. We need a huge data set and so many CPU or GPU to train a model. The upper layer is algorithm layer. The traditional machine learning algorithm can solve some problems, but when we need some more complicated scenarios to be solved, such like image processing or NLP, we need deep learning. Regarding the technical direction, there are several major directions now, such like image processing, audio processing, natural language processing, aids decision making, and big data statistics. Each direction can be divided into multiple applications. For example, the computer vision. 这一出来。Regarding the technical direction, there are several major directions now, such like computer vision, audio processing, natural language processing, and decision making, or big data statistics. Each direction can be divided into multiple applications. For example, the computer vision can be divided into image processing, image recognition, and so on. All the applications are widely used in different industries, like finance, medical, security, and so on. The development of infrastructure has significantly promoted the evolution of algorithms and technical layers. From the rise of computers in 1970s to the spread of computers in 1980s, the increase in computing speed and storage in 1990s, the improvement in hardware and computing power become a necessary factor in the rapid development of AI. We have so huge data to be processed, millions of parameters to be optimized. A strong computing power is essential. Regarding big data, massive learning data is an important fuel for the development of artificial intelligence. The scale and richness of data are particularly important for algorithm training. Since 2000, thanks to the popularity of the internet, social media, mobile devices, and sensors, the volume of data generated and stored globally has increased dramatically. According to IDC report, the total amount of global data in 2020 is expected to exceed 40 ZB, which is 22 times the amount of data in 2011. In the past few years, the amount of data in the world has grown at a rate of 58% per year, and the speed will be faster in the future. Machine learning refers to the use of algorithms to enable computers to extract hidden information from data as humans do. Deep learning, as a subset of machine learning, uses more parameters and models than other learning methods. More complex, making the model more in-depth understanding of data, but also more intelligent. Traditional machine learning is a step-by-step process. The manual selection of features is a time-consuming method that requires expertise and is largely dependent on experience and luck. Deep learning, starting from the original features, automatically learns advanced features combination. The entire process is end-to-end, and the advantage is that the final output is the optimal solution. However, the hidden layer in the middle is a black box. We do not know what features the machine extracted. Algorithms can be divided into supervised learning, unsupervised learning, and reinforcement learning. From another dimension, it is sometimes divided into traditional algorithm and deep learning algorithm. Use a sample of known or certain characteristics as a training set to build a mathematical model and use the established model to predict unknown samples. This method is called supervised learning. The most commonly used supervised learnings are classification and regression. Both of them are used in many scenarios. Regarding unsupervised learning, given untagged data, use machine learning to find the features of the data. The input data does not have dimension tags, or we say the labels. For example, the output can be clustered data. The human can put labels after classification. Reinforcement learning is also known as re-education learning or evaluation learning. Given data, choose actions to maximize long-term rewards. The input is the historical state, action, and corresponding reward, and the output is the best action in the current environment. And then let's see the technical directions. The accuracy of image processing recognition has surpassed the human eyes and has been widely used in face recognition, photo search, and so on. At the same time, large vocabulary continuous speech recognition has made breakthroughs and entered people's lives. Regarding the NLP smart translation products and dialogue interactions are used in customer service robots, smart assistants, and other products. For aid decision, in the 1990s, Deep Blue defeated Kasparov, and in 2016, the AlphaGo defeat Li Shishi, and humans have been unable to compete with AI in board games. And then I will introduce the applications of AI. Computer vision includes image processing. Now I will introduce the application of AI. Computer vision includes image processing, image segmentation, feature extraction, and judgment matching. Applications include face detection recognition, optical character recognition, and more. Speech synthesis mainly includes text analysis, linguistic analysis, sound length estimation, and pronunciation parameter estimation. The current research focuses on how to get closer to human voice. Speech recognition mainly detects the start and end of speech, background sounds, and vocals, echo cancellation. The current research focuses on far-field pickup and cocktail effect issues. Regarding natural language processing, the typical scenarios are translation and semantic understanding. In traditional methods, sentences are first split into phases, translated one by one, and then a fluent sentence will be created. Deep learning can establish a direct mapping relationship between the source language and the target language, skipping the intermediate complex feature selection and adjustment procedures. Semantic understanding is the biggest problem in natural language processing. The core is how to find an understanding that fits the current context.